Good day everyone. For today's video, I am going to explain three different topics, which is the conic sections, functions as mathematical models, and derivatives as rates of change. And we are gonna apply a real-life worded application from each topic. To the first topic, here is the conic section, an ellipse. On the example below, we have worded application and we are going to solve it step by step. Suppose you are in a whispering room that is in the shape of an ellipse. In this room, if two people are standing on the foci of the room, they will be able to hear each other regardless of which direction they are facing. If the elliptical room is 300 feet wide and 200 feet long, how far apart would two people be if one was standing at the center of the room and the other was standing on a focus? Assume at the center of the room is the origin. So according to the word problem, we are going to find the distance of the person standing at the origin and to the focus point. So on the first step, we are going to identify the length of the major axis and the minor axis through the given value of length of the whole ellipse. So our length major axis is the 300 feet wide and the length minor axis is the 200 feet long. So we are going to get the half of each axis to be assigned to the A term and B term. For this will be the solution in getting the C, which is the distance of origin to focus point. So, in the standard form of C squared equals to A squared minus B squared, we are going to substitute the A squared by our A term, which is the 150 feet, and B squared by our B term, which is 100 feet. So the equation will be C squared equals to 150 squared minus 100 squared. And we are going now to take the square root of both sides, which is C equals to C square root of 150 squared minus 100 squared. And through decimals, we can get the distance, which is 111.803398875. And our next topic is the functions as mathematical models, which we have the model application example below. So, here's the example. A customer is charged 100 pesos per 0 to 3 kilometers for renting bicycle. Exceeding of 3 kilometers is charged of 40 pesos. Represent the amount of a customer that pays per rent as a function of the number of kilometers that the customer consumes. So, according to the problem, the customer must pay according to the rent of the bicycle per 0 to 3 kilometers, which is 100 pesos. But if kilometer is exceeded of 3, the customer must add additional fee of 40 pesos. So here is the solution. The C represent of the customer, while K represent the kilometer. So if K is greater than or equal to 0 and less than or equal to 3, the customer must pay 100 pesos only. But if K is greater than 3, so according to the example, the K represents the pay amount, which is the 100 plus the kilometer exceeded, which is the 40 pesos. So we have to add the 100 plus 140. So that was 140 pesos, and then we have to minus it by 100 pesos. So we have the 40 pesos, and we have to add the pay rent, which is 100 pesos, which is the resultant total of 140 pesos. So lastly, derivatives as rates of change. Jasa weighed 130 leaves in 2018 and weighs 155 leaves in 2021. So our first step to get the rate of change is we must to determine first the y and x, which is the independent and the dependent variable. So our dependent variable here is the weight, and our dependent variable here is the year. Because gain depend on time or process, that is why weight is dependent and year can be dependent. So in order to find the rate of change of 2018 to 2021, we have to subtract the weights and years, which 155 leaves minus 130 leaves is equal to 25. And year 2021 minus 2018 is equal to 3. And in order to find the rate of change, is we have to divide the weights and years, which is the 25 divided by 3 is equal to 8.3333 and so on. And the 8.33 and so on is the gain weight per year. And for the summary of the video, there are a lot of learnings that I've got throughout to all the topics, and somehow what I enjoy the most and useful, especially to my course, is the inequalities, because inequalities are very common to us programmers to use it as logical operators. And what I've learned through from ID4, I just literally can apply it to my project in programming and made all my works easy just because of the learnings that I've got from calculus. So that's it.